Hello, welcome. My name is Jeroen van Bemmel, and this is the third part of an application demo showing how Nuage Network supports containers. In the first part, we've seen how containers can be used in all of the phases of the life cycle, DevOps cycle, not only in deployment as an alternative for VMs, but also as part of development, testing, and deployment. First demo I've shown was a sample web video conference application using containers on bare metal servers. And the second application demo I've shown is an elastic content delivery network application running containers inside OpenStack VMs. In that demo, I've shown how this is an elastic application, so you can scale up, you can add more resources, more containers, and the application itself will adapt itself. It will distribute the content requests over the available resources. But in a deployment scenario, you obviously don't want to have an operator constantly monitoring the part where how much resources are required and launching new VMs as needed. We want to automate that part. So for this demo, I'm going to show I'm using an open source component called fastnetmon. It's a DDoS attack mitigation tool. It's an open source tool. It's available on the internet, and they have a Docker container version of it available. So I've taken this container and I've configured it for my environment. I've launched it on this server in our network. This is the interface you see. It's monitoring for packets, and it can trigger events. It can trigger scripts depending on how it's configured. In my setup, I've used a host port on the VSG, so the container is running on a bare metal server. For the same I could give the same demo using a VM or a container attached to the network directly. So this doesn't depend on the 7850 VSG, but this is just to show that we can do this kind of service insertion using either hardware or software resources and in the same uniform way. So the way I'm diverting traffic to this DDoS mitigation container. I've defined a static route in the shared network here that says for the application IP address .10, go to the DDoS mitigation container .13. And the container, what it will do, it will just monitor the incoming flow of packets and then forward the packet back into the application for one of the two front-end VMs. So this is the application. As you can see, I can still use it. I can see my content.
Last year I made up a list of...
And as I do that, well, you can just see it there. So there's packets coming into the service. So I'm going to use a tool called Siege to simulate user traffic being generated on the CDN. It's making requests, and I've configured this DDoS tool to trigger when there's 100 packets per second or more. There it triggers. Of course, this limit could be configured in any way that you like, that makes sense for the resources that you have. And this first demo, what is happening underneath is triggering an additional VM to deal with the increased capacity that's needed to serve these new clients. And I can stop the traffic. It will go down. It's configured to wait for 30 seconds, and then it will release the resources and bring the service back into the original state. So as you can see now, if I refresh, the VM is gone, and we still have the two original VMs, a minimum configuration with redundancy to serve content to clients. Then, okay, so that's kind of regular operation of a CDN service. But what if you have somebody that's malicious, that's trying to attack your service and is creating, for example, a TCP SYN flood attack? So that's the second scenario here. I'm generating a SYN flood attack. As you can see, packets per second are up the roof. It's really going crazy. But now it goes down again. And what's happening underneath is that the script is dynamically programming a list of IP addresses that are suspected DDoS attackers. And this list is used in a policy, a security policy for DDoS mitigation on egress, and it says drop all traffic from any IP in that list of DDoS attacker IPs, both for hardware, for VST ports, and for software, so the VST, the container front-end VMs that are part of the application. So it does the same thing as before. It bans, it creates the ACL, it blocks for 30 seconds, and then after 30 seconds, what happens is it clears the condition. It will automatically remove the IP address from this list. And so, since the attack is still going on, the cycle repeats itself. And if I stop the SynFlood attack and I wait a bit, eventually the system is going to recover and reset itself to its normal state. All fully automated without any manual intervention from operators. And I should mention that the way we do service shading here is because we use standard BGP protocols for the service router that I have in this setup. Let me show you. In the infrastructure, I have a 1750 router that is providing the gateway between the underlay and the overlay. But for the same reason, this could be a Cisco or a Juniper MX, and the same application would work in exactly the same way. So there's nothing proprietary, nothing specific about specific hardware that you need to enable this scenario. This concludes my third demonstration. So containers on bare metal servers or inside VMs, and then the automation around it. Once you have a platform like Nuage VSP, it becomes really easy to automate the daily operation of your services, and taking advantage of all the features of Nuage, such as the dynamically programmable ACLs, both hardware and software ACLs, you can build real-life deployable applications that are scalable, and that are easy to deploy, and that are great for your customers. Thank you very much. I hope you enjoyed this demo, and I'll see you next time.